Okay, in my last video, we talked about how oxidizing is essentially getting rid of hydrogens to add extra bonds to oxygen. Here's the video example of that. We got rid of these two hydrogens, got an oxygen, now there's only one hydrogen, and got rid of that, and now there's two oxygens. So if that's oxidation, then reduction has to be the opposite of that. Reduction is getting rid of bonds to oxygen in favor of adding in hydrogen. So now here is some examples of reduction with some functional groups that are hopefully familiar to you. So here's an ester. You can actually swap out that R for a hydrogen, so it could be ester or carboxylic acid. If you get rid of the bond to this oxygen right here, you end up with an aldehyde. Then you take it one step further, and this all happens very quickly. It doesn't stop in the middle, but you take it one step further and you get rid of one of these bonds on the double bond there. You can cover up just one of them. And that adds on another hydrogen to the carbon right there in the very middle. So you can think about the carbon in the very middle gaining or losing bonds to oxygen or hydrogen. Ketone is very similar to this second step here. There's only one spot you can add in a hydrogen because there's two R groups. So you go from a ketone to a secondary alcohol. There's two R groups still. No other place we can swap out an oxygen to add hydrogen, so we stop there. And then very last is aldehyde, which you actually already saw over here, but it starts with a hydrogen already. There's only one place you can get rid of a bond to an oxygen right there, and that's what we do. So that's the different pathways for reduction for esters, ketones, and aldehydes. But there's actually two different reagents we can use to accomplish these goals, and I'll talk about those in my next video.